Hello and welcome back to the review for chapter 6. I'm going to share my screen, or actually share my paper here. So I think the review has 7 problems to it because we only did them 2 sections in chapter 6. So the first 2 problems are asking us to do some verifying of the identities. And on this one, because I am familiar with tangent squared x, I'm going to start with the right-hand side and get it to verify the left-hand side. Also, make sure that you check the updated answer key. There were a couple of errors in the answer key that I corrected, and this was one of them. So tangent squared x is the same as secant squared x minus 1. And then we have over secant x plus 1. Secant squared x minus 1 can factor into a difference of squared of secant x minus 1 times secant x plus 1 all over secant x plus 1. And then the secant x plus 1's cancel out, and we're left with what we wanted was secant x minus 1. And the answer key used to say secant squared x, but it's really just secant x minus 1. So the second thing we're going to verify here is the sum of these 2 fractions. And what I'm going to do is I'm going to get common denominator here between them. So it's going to be the difference of squares. We're going to have one of each. So the first fraction is missing the 1 minus cosine x. So this is going to be 1 minus cosine x over 1 plus cosine x times 1 minus cosine x. And then plus the second fraction is missing the 1 plus cosine x all over the product. And then when we add them together, the denominator is going to multiply to be a difference of squares. So 1 minus cosine squared x. And on the top, we're going to have 1 plus cosine x plus 1 minus cosine, or 1 minus cosine x plus 1 plus cosine x. So the cosine x's will cancel out, and we'll end up with 2 over 1 minus cosine squared x. 1 minus cosine squared x is the same as sine squared x. And 2 times 1 over sine squared x. And you can see that 1 over sine squared x is the same as secant squared x, or cosecant squared x. So it's 2 times cosecant squared x. For using what we know about our identities to solve that. Then number 3 is asking us, it says, write the following expression as the sine or cosine of a single angle. So this looks like the difference of angles, the difference of sine angles. Let me get my sheet so we can look that over together here. So it's sine cosine minus cosine sine. Sine cosine minus cosine sine. So it's the sine of a difference angle, sine of A minus B. So we have to figure out what was A minus B. So A must be pi over 4. And B must be pi over 6. And we need to get them into common denominators. So it looks like a common denominator of 12, which would be 3 pi over 12 and 2 pi over 12. So it would be the sine of 3 pi over 12 minus 2 pi over 12. So we really would have been looking at the sine of just pi over 12. The answer key for some reason had a 1/2 out here, so I removed that. I'm not sure if you saw that already. So that is the correct answer there. So make sure you have all the basic identities and some of the squared identities, the negative identities, the sum of different identities. On the note sheet, co-function identities, and the sum of sines and cosines. And then also the 6.2, the law of sines and law of cosines. Oh, sorry. So law of sines and law of cosines, chapter 7. That's not on there. My brain's in two different realms here. So no, chapter 7 is not on the exam. Okay, let's look at number 4. Number 4 says find the exact value of cosine of 7 pi over 12. So that can be thought of as the sum. So if we did cosine of 3 pi over 12 plus 4 pi over 12 is then the sum of pi over 4. We know information about pi over 4, and then pi over 3, and we know information about that. So we can then use our sum identity for cosine. Our sum identity for cosine is cosine A cosine B minus sine A sine B. So this is going to be our A and our B. So cosine of pi over 4 times cosine of pi over 3 minus the sine of pi over 4 times this, sine of pi over 3. I didn't need that parenthesis. So cosine at pi over 4 is the square root of 2 over 2 times the cosine at pi over 3, which is 1/2. And minus sine at pi over 4 is square root of 2 over 2. And sine at pi over 3 is square root of 3 over 2. So this becomes the square root of 2 over 4 minus the square root of 6 over 4. And we can write that together. So square root of 2 minus the square root of 6 over 4. So you have to kind of think of what are some of my common reference angles that I know that I can make to make 7 pi over 12. Number 5 is a similar one, but it's giving it in degrees. So we want to think of how can we make 105 degrees from some things that we know up here. So it's got to be a 45 and something. So 45 and 60. So this can be tangent of 45 plus 60. And then our tangent sum is, let's just write that over here. Tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. So this is going to be the tangent of 45 plus the tangent at 60 all over 1 minus the tangent at 45 times the tangent at 60. And then we can go to our chart. So tangent at 45 is a 1. plus tangent at 60 is square root of 3. And then 1 minus the tangent at 45 is 1 times the square root of 3. So we have 1 plus the square root of 3 over 1 minus the square root of 3. And we could try to rationalize that if we multiply by the conjugate to get a difference of squares. So 1 plus the square root of 3 over 3. So on top we'll have 1 plus 2 times the square root of 3 once you use your distributive here, plus the square root of 9 is 3. And then we're going to have a difference of squares on bottom. So 1 minus the square root of 9. So it'll become 4 plus 2 times the square root of 3 all over 1 minus 3. So we could factor out the 2 on top, and then we'll have 2 plus the square root of 3 over a negative 2. The 2's cancel, so I guess we just have negative times 2 plus the square root of 3. Now I have the answer key as this right here. 1 plus the square root of 3 over 1 minus the square root of 3, and that's fine. But if we rationalize it, we'd really get this down here at the bottom. Okay, the last 2 problems are sum and difference as well. So number 6 is the difference. So it says given that A and B are in quadrant 2, cosine A is a negative 4/5 and sine B is 12/13. Find the exact values. Okay, so let's draw them both. So A, cosine of A is a negative 4/3. So the adjacent is 4. So it looks like the other is a negative 3. Oh, it's in the quadrant 2. Whoops. Oh, I'm going up. Okay, so this is the 3, 4, and 5. So the 4 is negative, the 3 is positive. And then the other angle is in the second quadrant, and its sine is 12. So the opposite is 5. So this is 12, and that is 13. And that's another special triangle. That's a 5, 12, 13, if I remember correctly. And we will show that because that'll be B is equal to the square root of 13 squared minus 12 squared. So B is the square root of 169 minus 144, which is the square root of 25 or 5. So yeah, that's 5, 12, and 13, and that's going to be a negative 5 because we're in the second quadrant. So sine of the difference, so the sine of A minus B is right here. Sine of A cosine B minus cosine A sine B. So let's write that. Sine of A cosine of B minus cosine of A and sine of B. And then let's just write the tangent formula while we're at it for number 7 while we have them here. So tangent of A plus B, we just said that as tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, so sine of A is over here. So it's 3/5 This is our A angle and this is our B angle. So this is 3 this. And then cosine of B is a negative 5/13. Subtracting cosine of A, they told us is a negative 4/5. So make sure they're in parentheses here. And sine B is 12/13. So we have a negative 15/65, and that's a negative and a negative, so that's a positive 48/65. So that should add to be 33/65. Number 7. So tangent is opposite over adjacent. So the tangent of A is the opposite over the adjacent. So that's going to be in negative 3/4 plus the tangent of B is going to be the opposite over the adjacent. So 12, a negative 12 this all over 1 minus tangent of A, negative 3/4 times a negative 12 this. Okay, so we're going to take a common denominator on top of 20. So when we do that, refresh our memories here on common denominator. So if it's 20, we're going to multiply by 5/5. I need to replace my markers. Play this well. So we're going to multiply this fraction by a 5/5 and this fraction by a 4/4. So when we do, we get a negative 15/20 here plus a negative 48/20. So this becomes a negative 63/20. Okay, and then on bottom we have 1 and negative, 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 so it's 1 minus 36/20. And then running on the bottom, common denominator, we would end up with a negative 16/20. And so this becomes a negative 63/20 times the reciprocal of a negative 20/16. So those cancel. Negative times negative gives us a positive 63/16. And I don't believe that reduces to anything spectacular. 63 divided by 16. Nope, it doesn't. So we're going to leave it as 63/16. So if you have any questions at all, do not hesitate to reach out to me. I'm happy to meet you on the Zoom so that I can support you. And go kick butt on your exam.